Welcome, everybody. Welcome to the Paris Air Lab. This is the temple of innovation. You know how important it is to decarbonize air transport in the future and right now. And this is where it all happens. You can see so many innovations regarding the subject here. It's incredible. You have the sustainable fuels here. You have the hydrogen-powered engines, for instance. You can learn a lot about what again? About turbofans, for instance. They will explain everything about turbofans right there, or long span wings, for instance. So we need innovation, we need disruption, and you know where disruptive technologies come from. You know where they come from, not you. They come from startups. They come from startups. Only the startups have the agility, the creativity, and they believe that anything is possible. So they really have all that is required to create innovation. So that's the reason here at the Paris Air Lab, we had to host a startup pitch session. And we are proud to have 7 of them here in the next hour, all of which are going to present innovative ideas and products and projects which aim at decarbonizing air transport. So we're going to have 7 startups pitching here. Before we start to listen to the first one, can we have a big round of applause for the whole of them, please? And we're going to start with Jacques-Alexis Verrecchia from Beyond Aero. Could you come on stage with me, Jacques-Alexis? It's nice to meet you. So, Jacques-Alexis, you are head of project of Beyond Aero, and we're going to talk about hydrogen propulsion with you.
That's right. Do you have the slides, or should I just pitch like that? Is there some slides? Perfect. Well, thank you for having me here today. As you said, I'm going to talk about Beyond Aero, a French startup created 2 years ago that is targeting the development of a hydrogen-powered aircraft, business aircraft. So, yeah, that's me. Okay, perfect. So, as you said, the need to decarbonize aviation is quite urgent now, with the number of passengers expected to double by 2050, and the objective of reaching net zero in carbon emission by the same date. As you said, incremental innovations are not sufficient. We really need disruptions. And as the step is huge to reach that goal, the problem has to be tackled from all the angles. And the angle that we, as a startup, decided to address first, and I'm going to explain why we decided to address it that way, is the business aviation sector. So why the business aviation sector? For many reasons. First of all, it's a sector with a lot of aircraft. The fleet is huge, with 23,000 aircraft in circulation. To give you an idea, it's the same number as the number of airliners in circulation in the world. Of course, they fly way less, but it's the same number. And in average, per passenger, a business aircraft pollutes 10 times more. It emits 10 times more carbon dioxide in the atmosphere than a conventional airliner, again, per passenger. So we can see that the problem is quite huge, and we've all seen that there's also some public drivers, and the business aviation is under a lot of scrutiny and a lot of critics for it. So we've decided to address this problem with the aircraft we've revealed last Monday that you can see here. It's called One, quite simple. The idea is to transport 4 to 8 passengers, depending on the configuration, up to 1,500 kilometers, 800 nautical miles. Of course, with a switch to electric hydrogen propulsion, the performances are a bit lower than with conventional kerosene aircraft. But we've seen that with that configuration and those performances, we are able to cover a large part of the market, and I'm going to come back on that afterwards. And to achieve that goal, a lot of technical challenges have to be addressed. And I'm going to quote two of them. The first one is the heat you have to extract. You have to know that our technology relies on, our architecture relies on electrical propulsion, and the electricity is produced through a fuel cell. With a fuel cell, which is fuel itself by hydrogen and oxygen, with a fuel cell, for every kilowatt of power that you produce electrically, you have the same amount of power in heat, and you have to extract that heat. And this raises a huge challenge. You have to cool down the fuel cell system. So this is the first challenge. And the other one is that hydrogen, as you know, is a gas. It's very light. So in order to embark sufficient hydrogen to reach 1,500 kilometers, you have to compress it and put it in large tanks. Hydrogen itself, as I said, is very light, but the tanks are very heavy. It's compressed at 700 bars, and that's why we have two patents with the tanks underneath the aircraft and the TMS on the upper side of the aircraft in a croissant-shaped form that you can see there. So this is one of the reasons we decided to go with a clean sheet aircraft. We started from scratch, from a blank page, because doing a retrofit is, of course, a good solution in order to go quickly. But we wanted to really optimize the integration of these new technologies and the new constraints, two of which I have explained before, into the design. And also another reason we decided to go with business aviation is that if I came here today and told you, okay, we're going to build an A3 and an Airbus A320 equivalent with a fuel cell as a small startup, I'm sure you would have laughed. I would have laughed. And the idea to start with a below 8 tons aircraft, 8 ton 6 aircraft, is that the certification, which is called CS23, is a bit achievable for a startup. The idea is to be on the market by the end of the decade, whereas a bigger aircraft, such as an airliner, would require 10 to 15 years minimum in development in order to reach the criteria given by the CS25, which is the normative background for them. And starting from a clean sheet as well, we can see that we have very thin wings because there's no fuel in them, since the fuel is below the aircraft. And finally, in order to validate the market opportunity, the idea is to have an aircraft that is, of course, technologically feasible, but also economically viable. Why is that? Is that because in order to finance those disruptive innovations, you have to find the right market. The idea, the strategy behind that is that this will allow the technologies to be matured, to be developed, and then afterwards, they will allow us to go for bigger aircraft. In the same time, hydrogen will be available in more places. And with the aircraft I presented you, we can see that for the business aviation sector, we can cover 80% of the routes performed today, which solves a large part of the emissions of that sector, allowing us, as I said, to finance the next step. And of course, we've modeled the operational cost, but I'm not going to go too deep into details. But the idea is that switching to hydrogen is not that big of a deal in terms of operational cost, because the higher price you have for hydrogen, actually you gain it back because the fuel cell system is quite easier to maintain than a conventional jet engine with rotating parts, very high temperature. And to achieve such a goal today, and you can see it on our chalet, we have an 85 kilowatt subscale powertrain. The idea is to validate the architecture. What you see here now works, and it's gonna go back as soon as Monday, back to Toulouse, where we're located, in order to be integrated into a small ULA, a two-seater. The idea is that after the integration, which should last a couple of months, we will be able to fly before the end of the year, definitely, validating that architecture, and then for the upcoming 1 to 2 years, the idea is to take that, scale it up in order to reach half the powertrain of the plane you've seen, which is not 85 kilowatts. The new one is 1 megawatt, so it's a bit bigger, but the architectures will be the same. And of course, a final word on the company. To achieve such a goal, it's mandatory to be surrounded by very, very smart people. And that's why I believe our 3 founders, as you can see here, Eloa, Hugo, and Valentin, have achieved. And as of right now, we are around 30 people, and the company is a bit more than 2 years old, and we are raising fast. We are currently under a Series A funding, and I think that's it for me. Okay, the rest of the team, truly smart people. And yeah, thank you for your attention. And should you have any questions, okay, so that's the video of the reveal. It lasts 1 minute, and enjoy.
Thank you very much.
From scratch, carving around fuel cells, evolving fast.
Can I have the sound, please?
To
Est-ce que tu peux
achieve
ouvrir mon micro, s'il te plaît, Lucas? On va éteindre le son et on va prendre des questions. If you don't mind, we'll take questions now while we look at the video at the same time. Are there any questions for Jacques? Can we have a big round of applause for Jacques Alexis, please?
Thank you.
So are there any questions for Jacques Alexis, maybe, about this hydrogen-powered airplane? It's quite incredible because you've decided to start everything from scratch, no retrofit at all. But I guess this is more expensive, of course, to build, to create. Fortunately, you have big names in the field with you. I can see you have Airbus, Honda Jet, Daher. There are big industrials with you. But how much is it going to cost, and where are you going to find all the money?
That's a good question. We have some numbers of. I'm not sure I'm gonna share them with you, but of course the price of financing the whole aircraft is bigger than just financing the development of the powertrain. But the idea is that we are a system integrator. We're going to play Legos, you know. We're not going to develop a new wing. We're going to rely on people that know how to develop an airframe, landing gear, door, a fuel cell. We do not have the ambition to develop our own fuel cells, and we really believe that the sector of hydrogen and everything that goes around it is really developing fast, and yeah, it's such an amazing time to be in that position, actually.
Definitely. Thanks very much, Jacques Alexis. Congratulations. Can we have a big round of applause for Jacques Alexis? Thanks very much. I'll take that as well. Thanks very much again. So our next guest is Etienne Agabriel from Élise Énergie. He's the project manager of Élise Énergie. Here you go with the clicker, the microphone. And yes, we're going to talk about the first e-biofuel commercial plant for the aviation sector. It's incredible.
Thank you very much.
Yes, let's listen to you.
Good afternoon, ladies and gentlemen. So my name is Etienne Agabriel. I am the project manager of the Biotijet project in charge of all the engineering and construction aspects within Élise Énergie. I'm proud to be here today to introduce you Élise Énergie. So Élise is a French independent SME founded in 2020. pioneer in the production of low carbon molecules. So our target is to design, develop, finance, build, own, and ultimately operate our plants. We are focusing on two markets, on two molecules, sorry, e-methanol and e-biokerosene, to address markets where there is no direct electrical solution, considering that whenever you can have direct electrification, the efficiency of battery is much more interesting compared to liquid molecules. So we will be active in France and in the Iberic Peninsula. So basically, we are targeting three markets: air transport, shipping, and industry. And we are following four purposes. The first one, of course, is to decarbonize through the production of e-molecules, e-SAF, to support the achievement of European targets in terms of reducing of greenhouse gas emission. Our second target is to be part of the energy independence of the European Union through local production of molecules compared to imported fossil fuel. Our third target is to be part of the reindustrializations of our local economy and ensure, I would say, local production, local consumption, local economy, circular economy. And of course, we want to be a major actor of this emerging low-carbon industry that will drive the next 50 years to ensure the transition, the climate transition. So just a few quick overview of how we produce molecules. I invite you to, if you have more questions, to go to our partners of EFP and Accents, which have a much more detailed poster just behind. So to produce an e-fuel, you need carbon that we get from carbon capture or from biomass. You need to mix it with hydrogen that we get from electrolysis production. And we mix that into our, I would say, chemical plant to produce e-fuels. These e-fuels are today able to be used and consumed by the end user using the already existing distribution networks. So we don't need a new distribution network. This product can be used directly into today's existing infrastructures. And then, thanks to the circular nature of the capture of the carbon issued from the combustions, we have a circular use of the carbon, which allows to demonstrate over 80% reductions in greenhouse gas emission compared to the fossil fuels. So we've recently introduced our first SAF plant, the Biotijet project, who will be located near Pau in the southwest of France. So this plant will produce 110 kTA of liquid hydrocarbons, including a minimum of 75 kTA of SAF. So kTA means kiloton per year. So this 75 kTA represents approximately 20% of the French target of e-fuel for the 2030 objectives of the European roadmap. So if you have questions.
Thanks very much, Etienne Gabriel. Thanks very much again. Are there any questions for? Yeah, sure. Big round of applause. It's incredible what's going on. This is the first plant that is going to produce SAFs in France. Is it the first?
No,
the newest one.
It's the first plant
yes.
that will produce e-biokerosene using the biomass to liquid process that has been developed by Accents and EFP over the last 10 years.
Wow, fantastic. And how much is it going to cost?
Close to €1 billion.
close to €1 billion. So you see, when Etienne Gabriel talks to you about BioTjet, yes, we're going to create a plant, you have to figure out how much investment it is. It's a €1 billion project. It's fantastic.
Yes.
Yeah. So this is the kind of project we really need in order to feed the airplane engines with bio-kerosene.
Yes, that's what we need. There are several paths to produce biokerosene. We are working on several of them. This one is the most mature, using both electrolysis, hydrogen, and biomass.
Fantastic. Thanks very much, Etienne.
You're welcome.
And congratulations.
Thank you very much.
Etienne Gabriel. And now we will move to the company, which is called Veridian, and Bojana Rivnak is here with us. She's the business manager at Veridian, and we're going to speak with you about electric microliners. Fantastic. You have fans here, right? Yeah.
We have a big team here, and by the way, we are at the German Pavilion. So stop by if you're interested, or if you have more questions. We are always happy to answer any of them. So basically, hello everyone, and we are delighted to be here and present our company. So what is it, Veridian, and what we are actually doing? So basically, we already saw this picture in the previous presentation from Beyond Aero. So Schiphol Airport in Amsterdam. So basically, they banned the short-haul flights. And why is that? Because basically, the short-haul traveling is the most carbon-intensive. So the flights up to 1,000 kilometers, they produce 140 megatons of CO2 emissions yearly. And so what are we going to do with it? You know, right? In Paris, also, the traveling from Orly to Paris is now also prohibited. So it's like we need to do something. We need to find a solution before 2030. And that's basically what we do. We develop, build, and certify electric microliner for short-haul traveling. So we basically try to stay with very conventional design to ease the certification and also to allow us the shortest time to market. So to give you a little bit more overview of how our aircraft looks like, so it pretty much looks like a glider. So we have high aspect ratio wings for maximum gliding ratio. We also have single propeller with multi-engine configuration to ensure the safety. So we also decided within our team that we will think about certification since day one. So basically that's why our design will stay very conventional, but also we always keep the safety in the back of our head. So, and also adding to that, we also collaborate with a lot of partners, especially because we are based in Munich. So the German airspace scene is amazing. Also, the technology they're developing is really help us to, drive our product to the market. So we also conducted this year the first cabin study together with our partners, IDS. So our cabin would look more like a business cabin configuration. So we would have a very spacious cabin, and we will also be able to basically have on our board up to 9 passengers. Going back to certification, so as not my colleague, but friends from Beyond Aero mentioned, we want to stay within the CS23 framework, level 3, because it's less capital intensive as well. It's also helps us to achieve market much more faster. And again, we're trying not to be in the same category with Airbus and all the big players, because then it's really impossible to find also the capital for that. So when we talk a little bit more our market, so we know that there is 7.2 million departures per year on flights up to 400 kilometers. And for that, we only need 40,000 Viridian microliners to completely decarbonize the short-haul aviation in that sector. If we look a little bit more into the Europe scene, we have 3,500 airports in Europe, and pretty much a big part of it will be able to land also in those airfields. Also, we are looking very much closer to regional airfields, so underserved regions where you have no high-speed train connection, where you have no opportunity basically to travel there in any other modes of transport, only by car. And then, of course, if you have to spend 6 hours in the car, literally for business travelers, the time is money. So you want to basically maximize your output. So that's why we believe that those travelers would be happy to change if they have another way of transfer, which could be pretty much our regional microliner. And if we go to the next slide. Oh, yeah. So basically, we gathered a team of experienced individuals that have more than 10 years of experience in aerospace. So together with our team, we worked on 4 different electric demonstrator programs in the big corporations. So we have teams that have experience in aerospace. They have experience in automotive industry. We also got some investors on board and public funding. And again, I mentioned already, so the German ecosystem is extremely helpful. So we are thankful to our partners that provide us also the lab spaces. They provide us technology, and they're the ones that are our suppliers. So thank you so much for the presentation and for the opportunity to present our company here. And yeah, do stop by our booth at German Pavilion. We are happy to welcome you here.
Thank you very much, Bojan. I'll take that with me. Tell me, I saw that you had people from Boeing, from Airbus on your team. How were you able to have all these kinds of people come aboard on Viridian?
That's a very good question. So I think they really believe in the vision, and they really want to do something. And for example, our co-founders, they worked 10 plus years in Airbus, and they realized that the innovation, especially in this like regional air mobility sector, is not happening there. And so they wanted to do something, and that's why they basically created their own entity to have the opportunity to make an impact. And so mainly all the colleagues that are working with us and for us have not only amazing experience, but also the vision that they can build the aircraft, I wouldn't say of the future, the aircraft of today, because we actually want to certify it by 2030. So
2030, okay.
Yes. So we have to build it now, and we have to basically innovate now, because otherwise it would be too late.
So at what stage are you in the development of this aircraft?
So we started 2021 with a very small team of 4 people. Now we're 23. We are working, so we are basically in the conceptual design phase. We also started with a testing campaign this year, so hardware testing. So yeah, basically developing a lot. Also, we're looking for basically possible cooperation with airlines and also for next funding round.
Fantastic. Thanks very much, Božena. And now we will switch to our next guest from We Fly Right Electric. Jeffrey Angler is the founder and CEO of the company. Hello, Jeffrey. How are you?
Testing.
Does it work? Yes, it works.
Testing.
Can we have a big round of applause for Jeffrey Angler, please? We're going to talk about the world's first family of zero-emissions commercial aircraft.
I have the clicker.
It'll be easier.
Thank you very much. All right. Hello, everyone. My name is Jeff Angler. My name is Jeff Angler. We build motors for electric airplanes. As everybody knows, flying is very bad for the environment. You would have to eat vegetarian for over 1 year to offset the carbon of a single 4-hour flight. Electric has a lot of benefits, not only because of the much lower overall greenhouse gas emissions, but also because of the substantially lower noise that's emitted. So if any of you have heard any of the airplanes flying overhead, you might have an understanding of some of the noise associated with the aerospace industry. Our company makes motors. We built a 2-megawatt motor. That's, I think, one of the most powerful motors that's out there. We announced on Monday we've already tested it to 1 megawatt, so that's about 1,300 horsepower. And we've tested it in sea-level conditions, and we just announced an agreement with NASA in the United States to go to their altitude chamber and test it up to 40,000 feet. We do work with NASA, the U.S. Department of Energy, the U.S. Air Force, and the U.S. Army as well. We're putting this into a regional jet class airplane, 100-passenger airplane, a retrofit. We're also looking at large turboprop applications like airplanes like the C-130. We also do work in terms of power generation. So we announced yesterday that we have a partnership with the U.S. Air Force to take the underlying technology in our motors and put them into next-generation generators for the U.S. Department of Defense. We have a laboratory in the United States. We're in upstate New York. It's a full-featured laboratory. It can do testing of motors, generators, power electronics, all the way up to the megawatt class. There's very few places in the world that can do testing like this. We have it in our facility for rapid innovation and iteration. One day I'm going to learn how to use this clicker. So why do we work on the propulsion system? What most people think of a new airplane like the Boeing 787, and they think, wow, that's amazing. 15% fuel savings over existing airplanes. Turns out that a lot of that savings, a lot of those benefits actually come from the propulsion system. So that's why we work on the propulsion system. And why are we focusing on such a large airplane when so many people are working on small airplanes? It turns out when you look at the carbon footprint of the aerospace industry, well, believe me, I will tell you that when you look at the carbon footprint of the aerospace industry, only 2% of the carbon is associated with relatively small airplanes, smaller than 80 passengers. 98% of the carbon footprint of the industry is large airplanes, 100 passengers, 150 and larger. But one of the interesting things, as was mentioned earlier, is that a large fraction of those flights are relatively shorter than 800 miles. So that's why we're focusing on this market. It's a large fraction of the carbon footprint of the aerospace industry, but we're targeting relatively short flights. And in terms of energy storage, I've decided I'm just not going to use the slides anymore, so you guys can all just imagine that there's really nice slides behind me right now. The reason we're focusing on...
Jeffrey, excuse me, if you want slides to move on, you can just ask for the slides for next slide, and they will...
Perfect. Next slide, please. And that was the slide about 2% of the carbon footprint of the industry. And then next slide again, please. Much bigger number in orange as opposed to the smaller number with 2%. And then next slide again. Lots of forms of energy storage in development right now. Hydrogen fuel cells were discussed earlier. Our company for the last year has also been working on a form of ultra lightweight batteries made from aluminum and other forms of metals. And I can talk about that if anybody's interested after the break, because I know I'm running out of time. Next slide. It's a very large market, so if anybody's thinking about getting into this industry, we're talking about trillions of dollars of future airplane spend and thousands and thousands of new airplanes purchased over the next 20 years. Next slide. We have a fantastic team. Oh, actually, next slide after this, excuse me. We have a fantastic team. Next slide, please. We have a fantastic team of about 20 people. We're based in New York. And our team is growing. We're hiring engineers both in the United States and Europe. So if anybody's interested, happy to speak with you after the break. Thank you very much.
Thank you very much, Jeffrey. Tell me, so you're going to retrofit an existing aircraft, right? It's BAE 146
Yeah, that's correct.
aircraft.
Starting with retrofitting airplanes.
Sure.
Correct.
So tell us, why did you choose that? Is it because you want to be on the market really quickly and time to market is key?
Yeah, that's exactly right. There's benefits to retrofitting. Obviously, some of the folks here have been talking about clean sheet airplanes, and we think that's a great strategy also. So we've been focusing on the propulsion system. So getting to start with a retrofit allows us to get to market a little bit more quickly.
So when do you expect this airplane to be commercialized?
We're looking at the second half of this decade, so before 2030 for commercialization.
Okay, fantastic. Thanks very much, Jeffrey. Thanks very much for passing by.
Absolutely. Thank you.
Thanks. So our next guest comes from a company which is called Nabla Mobility. Sang-Yang Lee is his name. He's the business development general manager there. And we're going to talk. Yes, what I understand is that you're going to bring AI in the aviation navigation systems in order to optimize the aircraft trajectories and maybe save fuel, I guess. Fantastic. Here you go. Can we have a big round of applause for Sang-Yung Lee, please?
Thank you. Thank you. Okay, cheers. Okay, works for mine. So, thank you for having me here. And I'm Sang from Nabla Mobility, and I would like to introduce our company and what we're doing in here. And we are started focusing on the optimized flight operations. Okay. Next slide, please. Sorry. So there are 4 large pillars for decarbonize the aviation industry. One is a renew equipment for new aircraft, and sustainable aviation fuel, obviously, and the new air mobility like UAMs that you've seen at behind of the booth. And last one is, okay, what's happening here? So the last one is operational optimization. And compared to other 3 levers, operational optimization is, well, commonly understood is, well, there's a limited room to improve. There's already a lot of things happening here, like single taxi engines, like stuff like that. But really, I mean, like, haven't you guys experienced a turbulence and have a scare memory about it? Haven't you guys lost your luggage and missed your connection flights, delays, and crying in front of the airline's desk to help you to get from place A to Z? So, yeah, to be honest, operations is still far from its ideal state. And simply, why it is? Why it is still far? Because its operation is simply a complex problem to solve. So when you fly the aircraft, you encounter lots of uncertainties there. Wind, turbulence, traffic, temperature, lots of things are coming in front of you. And then nextly, if you're a pilot, you have to consider a lot of things. For example, safety, punctuality, comfortness, service, economy, environment, lots of things you have to do. So what you have to do is look at the future, but also consider lots of objectives in the real time, and you have to fix the things. And currently, most of these comprehensive optimization work is done in pilot's head because of most of the solutions in the market is single objective optimizations. So let's say, like, if you're a pilot, you have to read lots of things before your flight, like flight plans, the turbulence reports, and the weather forecast from the various sources. But when you get into air, you will experience the unexpected turbulence. And what you have to do, there's a huge time pressures in there. You have to decide within like 3 to 5 minutes by considering the other traffic, also routes. Also, you have to communicate to the ATCs, and you have to eventually get a decision. Currently, there's a pilot doing on their expertise and the knowledge, and they want to check is it optimized or not, but this can't because there's no single flight same the world. So our solution with Weave is a unique combination of the machine learning and AI prediction technology to give you a better transparency of the situation, and combined with the multi-objective optimization algorithm, which consider like which mimics the pilot, what pilots are currently doing in their head to the system. So the pilots can make their decision in more safer and better efficient manner. So we are currently focusing on, firstly, we are focusing on the turbulence avoidance because the turbulence is one of the largest, let's say, the largest cause of the safety incident in aviation. And also it is expected to increase in the future because of the climate change. So our turbulence avoidance and the altitude optimization solutions is expected to increase the safety, and in the fuel efficiency term, we believe we can reduce up to 5% of extra fuel in the cruise phase. So based on our solutions, pilots, they don't have to anymore to calculate about the complex math problems and have to understand the deep in things, because we will show the optimal way to avoid within this vertical flight profile. And if you want to provide the safety, we can give you the file. And if you want to provide the fuel, let's say if you're flying a cargo flight, and we can give it too. So based on your priority, you can just choose a solution from our web and reduce your cognitive workload and just focusing on the real important thing by using our solutions. Okay, skip. And yeah, it is really difficult challenges we hear, but we have strong team to support this. So our founder, Shinji, is an experienced aircraft engine engineer from MIT and IHI, also have a BCG. And Makoto has a PhD from University of Tokyo, and he has worked for various startups from the senior to CTO role. And our team is also supported by the various people from, for example, from NASA or the ex-CEO and the president of NetBlue, and also people from ATC, so we can develop a comprehensive optimization solution for the airlines. And so far, we have resonated by the lots of stakeholders within these 3 years. So we recently got invested from the Boeing, and we are currently working a partnership with the Japanese largest LCC, Page, and also working with the JAXA, which is the Japanese version of NASA's. So in the future, we won't keep these solutions in just single flight optimization. We want to broaden this opportunity to give you the comprehensive optimization. For example, not just for turbulence, for the tropical weather, icing, the contrails, lots of stuff are there. And for the cost perspective, for example, maintenance costs and personal and the delay costs and network disruption costs, there's a lot of costs that management can see but pilot can't see. Ideally, we want to achieve the world that the pilot's decision making is not just for only the single flight, but also in optimal manner in the perspective of management, airlines, and the passengers. I hope you enjoyed it, and thank you very much.
Thank you very much, Sang-Young. Come with me here so we can have a nice talk. Tell me, here, this is the temple of decarbonation innovation, okay? So I understand that your solution will help me as a pilot to use the best route to go to another point, avoiding turbulence. Can you help me as well reduce my CO2 and the NOx emissions as well?
Yes. So our solution is basically, so how we deliver the fuel reduction is basically we want to use engine in the optimal way. For example, not just avoiding turbulence, but also catch the tailwind and catch the optimal temperature and optimal wind situations. So in that case, I said that there's a fuel reduction, but the emission should be the optimal way, like reduced in the very much in our solutions, flying by this optimals.
Anyone else? Well, thank you very much, Sang-Young, again, for coming with us.
Thank you very much.
Thank you very much. I'll take the microphone, and maybe we will leave the clicker here. I'm not sure we're going to need it anymore. Yes, let's move on to Jean-Pierre Barbeau. He's the CTO for Flynn Aero. How do you do, Jean-Pierre?
Very well, thank you.
Fantastic. And Flynn Aero is developing a software solution in the domain of the computational fluid dynamics.
Exactly.
I guess the best is maybe to just say next slide, next slide. I'm not sure it works so well.
Okay, so next slide, please.
Okay.
So here we are, and hoping that towards the cleaner air, sorry, maybe back. Previous. Next. Okay. Yes. So in fact, the idea is previous. Toward the cleaner aerodynamic and technological solution is on the way. And very pleased to present Flying Aero and our work. So next slide, please. So Flying Aero is a startup. We are acting in the field of external fluid dynamics, so no hydrogen, nothing like that. Our specialty is modeling and digital simulation, and we have a product. Our product is a software. Two targets. The first are the design office to create new airplane, and the second target is the flight simulation. Next slide, please. So Flying Aero is a team. So we are a team here, and I am Jean-Pierre Barbeau, the technical direction. Next slide, please. And the context, yet we are in an aeronautics sector that is facing to very new challenges: environmental, economical, societal. Environmental, we want to reduce the environmental impact of aircraft, and as the previous presentation says, we are also facing to new environmental effect, new occurrence of air turbulences that impact, for example, the flight, the landing, the takeoff, and the consumption of the airplane. So we have to take it into account. Economically speaking, there is a lot of fluctuation of energy prices. You know it, as I do. We want to reduce the operating cost, the duration of the previous, yes. And in fact, we want to benefit to new innovation opportunities to develop new aircraft that will be zero impact and so on. So, and the societal impact is very important also, because the impact of the air transport had been degraded due to its consumption, and maybe it's now the time to react to this. And we are also facing to climate disruption. You see that it's very hot today. So Easy Fluid is a software, a tool that can help you to optimize the aircraft design, to tend to a zero emission flight transport, to help to decarbonize transport, and to reduce the time to market, and to make free the creative energy. So next slide. Easy Fluid, our product, is a simulation software. Why are we simulating? Why means simulation? Simulation is the starting of the process of the design of a new aircraft. When you want to design a new aircraft, if we decide together today, we will build the aircraft of the future, we need 10 years, only 10 years, but 10 years, it's very long. If we can shorten this time, it's a very good idea. And if we can also test, and why are we facing to new défis? Because new challenges. Because in fact, we want to change our energy to use sustainable fuels like hydrogen. We will need new tanks, maybe five times larger, so new aircraft design, new shape. And it will be the time to do something fast. And to make it faster, we propose our simulation software that is based on direct 3D techniques. It's a non-iterative, that is to say it's very fast. It's based on a technique that had been developed by CNRS, the French research organization, and in ENS also in Applied Physics department. It's a fast technique. It's complementary to classical CFD techniques like a finite element method, maybe you know, Lattice-Boltzmann and so on. And it's perfectly suited for model reduction. And then we are at the second part of our application, that is the flying simulation. Because if you want to have good pilots well prepared to drive a new aircraft and so on, the possibility will be to use simulation tools. So easy fluid is fast and easy to parameterize. Next slide. Yes. We are not the first to propose to simulate aircraft. Classical technique, if you want to simulate, for example, this six shape, you will need an engineer during 2,000 hours to design the shape of the simulation frontier and then to learn the calculus. And after 6,000 hours, that is to say 8,000 hours, you will have the result of one solution. Okay? So what we propose, next slide, it is to make it decrease. Only 1 hour for this, so 2 hours at least. Next slide, please. And then this software solution being faster, in fact, it will accelerate the search of a optimized new shape. It's also well suited for artificial intelligence design method to try to find for a given volume, for a given shape, for a given size of the aircraft, the best shape that will maximize the lift force, because you want your plane is flying, and to make decrease the drag, that is to say the consumption of your aircraft. So it's a solution for design office, but also for flight simulators, and we have made some proof on trials and proof of concept using flight simulators, full flight simulators. Next slide. So the commercialization by a SaaS solution to design office. And next slide. The commercialization as an add-on. Sorry, it's missing a D. An add-on for flight simulators. And this is the flight simulator we have been making tests to test, in fact, our solution and to reproduce the landing and the takeoff process, procedure, in fact, to give a best formation to the pilots and to introduce real-time physics. A short input here. Maybe you have played with flight simulators when you have been younger. What you must know, there is no physics inside the flight simulation into the flight simulator. What we propose with this method, it is to introduce realistic physics to have best formation of pilots and then to make them more safe. And if you are using this simulator, you are not using a real plane. So you participate to the decarbonization of civilian aircraft. You can introduce some very difficult and critical situation to have good formation of your pilots. So you will have very good pilot. And next slide, please. So they support us, BPI and so on, the CNRS and a lot of people. And we have a lot of projects, and we hope to participate, for example, to the co-development of the next presentation will be made by BSA. So we are a partner of their work. Thank you very much.
Thank you very much, Jean-Pierre. So what I understand is you really come with a solution, okay, that's able to compute aerodynamic phenomena, for instance, on a wing, that type of thing, much quicker than the actual systems that can do that. But what will be the link between your capabilities, what you propose, and decarbonization? Is there a link?
Yes. In fact, the idea is to shorten the time to market. You have a lot of solutions, maybe, and you have to design an aircraft. We are now facing to something very new. The airplanes are all the same because they use the same fuel. Now we want to use hydrogen, for example. So maybe the shape will be bigger. It has to change completely. So the idea is we want to change everything. We want to change also the shape of the aircraft, and then the faster is the better.
Fantastic. Thanks very much, Jean-Pierre, again.
You're welcome.
For coming with us. Thanks so much. And our last guest, who works with Jean-Pierre, as I understand it, is Florian Pasquier. He's the project manager of Blue Spirit Aero. Florian Pasquier.
Good afternoon, everyone. I'm here to present you the project from Blue Spirit Aero. So if we go to the next slide, I'm gonna explain. So the project was founded 3 years ago with the conviction that we can solve the 3 problems that are happening right now in the flying schools. So if we go to the next slide, we see the flying schools is currently really old. The flying schools fleets, they are 45 plus years old. And it's really harder to maintain, it's hard to find new parts, and it's also a very noisy fleet. Once in a while ago, the aircraft and the airfields, they were really remote areas, there were no suburbs and people around, but now there are like new habitations have evolved and they are around, and they are complaining more and more about the noise and the pollutant emission that is emitted by these operations. So this public pressure is causing problems for the flying schools to operate the aircraft and train more and more pilots. There is the need to train these pilots because the aviation is back to its pre-COVID level, and now it's back on this growing trend. So, and also there are new markets that are emerging. So there is going to be the need to train a lot of pilots, and we need new aircraft for that. So the solution that I'm presenting in this, the next slide, is the solution that we found. So it's a 4-seater aircraft. There's actually a video of it spinning. So you can see it's a 4-seater aircraft. And to use it, we decided to go with hydrogen. So hydrogen paired with fuel cells. And the fuel cells, we distributed them on a special architecture, this architecture which we call distributed electric propulsion. It's the best use, in our opinion, for the hydrogen fuel cell, because you have smaller systems that are easier to maintain, easier to develop, and also easier to operate. So in each of these powertrain, you have a hydrogen tank, a hydrogen fuel cell, which then powers the electric motors. It allows for a system that is very independent. So in flights, you don't have a single point of failure. If one happens to fail, there is no propagation of the failure to the others. And then, so you see the propulsion is outside, the storage is outside, but then the cockpit and the cabin is the only safe for this is to transport its payload and its passengers. It allows to have a very comfortable cabin with a large field of view. And since this powertrain is electric, it's no noise, there is no pollutant emission, and it allows the flying schools to operate earlier in the morning, later in the afternoon. And if one powertrain was to fail, then you would go to the workshop, remove the failed pod, replace it with one that you previously stored in your workshop, and the aircraft is back in flight, and the flying schools can keep operating with their intensive fleet. Right now, so the company, as I said, it was founded 3 years ago. We have 15 people, and we started the first demonstration of a 1/4 scale demonstrator that is flying. And so we've been granted for the project France 2030 with a partner, Dassault Systèmes and Soben, to have the first demonstrator of this aircraft flying by the end of the next year, so by the end of 2024. And then we are also preparing the certification of this aircraft. It's a CS25 aircraft, so the certification is going to last for about 2 years. So we'll be able to deliver the first aircraft to the first client at our flying schools by the end of 2026. And so we're based in Toulouse, and we are happy to be developing this and to participate in the decarbonization of aviation.
Now, Florian, tell me, so this works on hydrogen, right?
Yeah, exactly.
So you're going to have fuel cells there, and you have tanks filled with hydrogen at 700
hydrogen.
bars.
Yeah, it's hydrogen tank, 700 bars that then is providing its hydrogen to the fuel cell, and the fuel cell is taking air from the ambient air and bonding it with oxygen in order to generate electricity. And the only byproduct that you have is going to be water. And so this water is just back in the air, and it's like a virtuous cycle.
And one of the fears that is associated with hydrogen is, hydrogen when you mix it with oxygen, and there's a lot of oxygen in the air, it gets inflammable, it can explode. How much of a concern is that?
Well, so for that, we have the hydrogen that is stored outside of the tank. And if you're bonded with air, there are very specific mixture to generate this explosion. So that's also, there is good ways of operating hydrogen, bad ways. And I think we think that this way of using distributed electric propulsion is the best way to operate hydrogen under these conditions.
2026 is the moment when you're going to fly first?
No, to certify, to deliver the aircraft. 2024, then
2024.
end of 2024. So next year we've flown a one-fourth scale mock-up. So it's already flying. We're seeing what's the handling qualities and how we operate. And then in 2 years later, we'll be able to, like 2024, fly the full-scale aircraft. It's going to be very exciting for us.
So what are you going to show us at Le Bourget in 2 years' time?
Well, we'll see. We're hopefully going to be that, and it's going to be very exciting. You'll see a quiet aircraft, so you can be doing conference while there is our aircraft flying. So it's pretty good.
Pretty good. Fantastic. Bravo, Florian Pasquier. Thanks
Thank you
very much. Well, this is it for our startups pitch session. We're going to have congratulations first for all of our guests. It was incredible because, we can have a big round of applause for them. It's incredible how much innovation is going on at the moment in order to decarbonize all the air industry and airplanes. We have appointments tomorrow. Yes, a fantastic appointment. Would you like to meet the leader of the Patrouille de France? You know, the Patrouille de France, there are these 8 aircrafts going up there. We will see them tomorrow. It's incredible what they do. They're all military people from the French Army, from the French Air Force. And the leader of the Patrouille the Patrouille de France will be here with us on stage. And we will also have the 7 other pilots from Patrouille de France here with us. And we will arrange a meeting, an incredible meeting between this leader of the Patrouille de France and an astronaut, an actual astronaut who is Jean-François Clairvoy, who flew 3 times with the US shuttle. So it's going to be incredible. It will be at 11 a.m. tomorrow. And for now, it's over now. Thanks very much for coming to Paris Le Bourget. And yes, I hope you're having a good time. I hope to see you tomorrow, 11 a.m. Bye-bye. Have a good evening.